Hello everyone, you are welcome to today's lesson. Today's lesson is going to be a very short one. Okay, our task is basically to look at the solution to the team assignment on the topic matrices, just as you have on your screens. Okay, so without much ado, quickly let me go and walk you through the solution. Okay, so we have, I think it were about 4 questions or so. So question one of the team assignment is exactly what you have here. So this, okay, is or was the question one. Okay, so as usual, as you read question, remember, you make it a habit to underline the salient part. So here, question 1A, we've been given these two matrices, and we are asked to find, okay, the matrix 2A plus what, 3B. Okay, so this was where I think one of the easiest, okay, of all the questions. Okay, so in this case, basically we are dealing with, okay, algebra of matrices. That's all about the question one. So after reading the question, underlining the salient part, if any, the first thing that you write is what solution. Here we realize that there is nothing salient for us to underline. So we come and write, questions are numbered because your solution equally must be numbered as well. So you come and write your major question number one and your minor question number A. And you extract the two given matrices. So given, then you extract the matrices in the form that they came. They came in the ordinary brackets. So please take note, those of you who put, okay, the matrices in square brackets, okay, though they have the same meaning, but that's not what you were given. So please take note. When you are extracting, you have to be very precise and equally concise in your, okay, extraction. So at that point, I know once I know these two matrices, I'm more than able to find the matrix 2A plus 3B. So on that note, somebody can write this implies, okay, or because I know you are equally matured, you can write therefore, because if you write implies here, then you are now going to draw your conclusion. So per experience, we can have our conclusion embedded in our presentation because of our steps here, because we know that this is the quantity that we are going to conclude with. The same quantity that you write here will be the quantity that we conclude with. Nothing will interfere. So I write therefore 2A plus 3B that I'm asked to find will be equal to 2, my matrix A I substitute, plus 3, okay, my matrix B equally substituted. Then now you know how to multiply a scalar and a matrix. So you do that here, it will be each of the entries here times for the scalar, 2. So that will give us 4 times 2, 2 times 1, 2 times 2, 2 times 3, and that will give us this. And you come and do same here. The matrix here times the scalar. Each entry must be multiplied by the scalar here. So that will give us the result that we have here. Okay, so at this point now, we can use okay, matrix addition to deal with this one directly. Okay, so at this point, what do? Matrix addition, we add corresponding entries. So it will be 8 plus 3, which will give us 11, 2 plus minus 6, which will give us minus 4, 4 plus minus 3, which will give us 1, then 6 plus 12, which will give us 18. So this then becomes our final answer. Okay, remember, therefore is here. So our conclusion is embedded in our steps. Then after that, you move on to question B. That's where most of you, from your submissions, okay, you got it wrong. Okay, so this is it. You are giving, again, the matrix, two matrices here. Okay, and we are asked to find P squared minus Q squared. Okay, so at this point, this is all that you need to know. Okay, yes, some of you wrote this, but because in our lesson, we realized that matrix addition is not what, multiplication is not commutative, I should say. If you come and write this P plus Q, write this or treat it as difference of two squares, okay, into, okay, P minus Q. Okay, you know, in ordinary algebraic expression, this is valid. Okay, this is valid. However, because you know equally somebody can write P minus Q, okay, also times what? Okay, P plus Q. Take note. But because matrix addition is not commutative, because these two can be written in these two ways, I'm talking about this can be written in these two ways. And you know matrix multiplication is not what? Commutative. It means if somebody writes it this way and another person writes it this way, you all get different results. So if you go this route, you are wrong. Okay, so all that you need to know is that p squared means p multiplying itself, okay, twice, and q squared, okay, the same meaning. So p squared minus q squared will be equal to, what is your p? P is this, okay, squared. And remember, you cannot write squared on the matrix. Remember, or even if you write square on the matrix, okay, what are you supposed to do? You cannot say that when you are squaring matrices, you know, okay, you are squaring each of the terms. No, you cannot say that. Okay, if you do that, that is totally wrong. Okay, you can't come and write your matrix here and say that the matrix square means you need to square each of the entries. No. So you use the basic meaning of what? A quantity square. That would mean the quantity multiplying itself twice. So you can see that that's exactly what I have here. Then minus q squared will also be q multiplying itself again. Okay, so at this point, what do? You come and use, okay, the row by column multiplication, okay, concept to deal with this multiplication, then same here, method of multiplication. Okay, so that is what I did, but I did that mentally because at this point, we should all be mature. So you know this will be 2 times 2, which will give us 4, then times minus 1 times, plus minus 1 times 1, which will give us minus 1. That will be for the first entry. Then you come to this one, so it will be 2 times negative 1, which will give us negative 2. Then plus minus 1 times 3, which will give us minus 3. Then you come and take this row, multiplying this column and that column. So it will be 1 times 2, which will give us what? 2 plus 3 times 1, which is 3. Then you come and do 1 times minus 1, which is minus 1, then plus 3 times 3, which is 9. So that will be it for the multiplication of this. Then you come and do same here. Okay, 5 times 5, which is 25, plus 2 times minus 4, which is minus 8. Okay, then you come and do 5 times 2, which is what? 10, then 2 times 0, which will give you 0. Okay, come and take this row, this column, this row, this column, just as we did for the first one. So minus 4 times 5, which is minus 20, then plus 0 times minus 4, which will give us 0. Then minus 4 times 2, which is what? Minus 8, then plus 0 times 0, which is what? 0. So at this point, you know how to simplify each of the entries here. And that will give us what we have here. Oops, so forgive me. So that will give us what we have here. Then minus, come and simplify each of the entries here too. That will give us this. So at this point, okay, you subtract, okay, these two matrices, and you know what do? You subtract corresponding, okay, entries. So it will be 3 minus 17, and that will give us minus 14. Minus 5 minus 10, so that will give us minus 15. Then 5 minus 20, that will give us 5 plus 20, which is 25. Then 8 minus 8, and that will give us what? Plus what? 60, because to be 8 plus 8. So that will give us this result. So this becomes the solution, okay, to question B. And the main note in question B, okay, is to let you know that whenever we are talking about square, you don't square each of the terms or each of the entries, okay, or element in your matrix. Take note. The square, you have to treat it as what? The quantity multiplying itself. So it means if it was cube, it would have been this times itself again. And you don't write it this way. Because if you write it this way, I've told you, somebody, in terms of this factorization of difference of two squares, you can swap the terms. But because multiplication is not commutative and matrices, if you use this approach, you will be wrong. Because the result here will be different from this result, okay, from hindsight. So this approach, as most of you use, will be wrong. And those of you who also square the entries, okay, it was an assignment, teamwork. So at least you could have done your research, what have you, okay, and to get you well informed. At least, okay, we are still learning. So take note of, okay, these corrections and advice and instruction that you've been given as far as the question 1B, okay, is concerned. So quickly, let's look at that of what question 2. Question 2A, we are supposed to evaluate. So whenever you see this sign and you have the entries there, so it's like you have a matrix and you are finding the determinant in a cell. So remember, this is not a square bracket. So this is a cell. So you are finding the determinant of your matrix here. That's the meaning. Okay, so how do we deal with that? So solution, there's nothing salient for us to underline. Solution, major question number 2, then A, giving, you extract whatever that you are giving, and you are asked to find the determinant, and we are experts in finding determinants. How do we find determinants? We know determinants will be, you multiply the leading diagonal entries. Okay, so people, let me take my laser pointer. So we multiply the leading diagonal entry. So it will be 7. This is a monomial times this what binomial. So you write it as you put the binomial bracket. Then minus, you multiply the minor, okay, diagonals or the other diagonal. Okay, so that will give us x times what? This is also a binomial. You put it in bracket. So you come and expand this, then you expand what you have here and simplify. But at the point that I'm simplifying, I know, okay, that I will land at my result. So at that point, I can draw my conclusion. And those of you who are smart, okay, and are now matured can also write therefore here instead of the given. So it's allowed. In that case, if you put therefore here, you are not supposed to come and write this. You end with equal to this statement. So the determinant of this matrix will be equal to s squared plus 21. So please take note. All right, then you come to the B. Okay, so the B, what are we giving that y is equal to? So this is the matrix y. Find the value of x if that y is equal to 0. So as usual, you extract. And the condition that you are asked to use to find the x is this. So you equally come and write, but that y is equal to 0. So that y means the determinant of what? Of y. So the determinant of y from where we are coming from, you multiply the leading diagonal entries, then come and subtract the product also of what? The other diagonal entry. So please take note of that. So this implies that we are told that the determinant will be equal to 0. But the determinant, so this statement here is an equation. So that's why I started with implication. This was an expression. So we start with equal to. Take note. By now, we should know the difference. So this implies that 3 times 8 minus, so somebody could have written 24 there straight away, then minus this times that. Okay, that's what we have here is equal to 0. So you come and multiply that. That's if you kept this one as 3 times 8, okay, you come and multiply to get 24. If you wrote 24 here, you still keep your 24. Then now you keep your negative and come and multiply, okay, these two by keeping the negative outside. So it will be x multiplying all the terms here, which will give us the first 2 terms here. Then the 2 multiplying all the terms here, which will give us what we have here. Still keeping the brackets. Okay, so it's now that I'm going to combine. Okay, so because I've seen that what I have in bracket here, I can, okay, combine like terms, simplify. Okay, so someone who is mature can combine like terms and push the negative straight away. So meaning the person can move from this step, okay, to this particular step. Okay, however, I decided to do it systematically. So if you skip, if there is any mark here, you will get it here as well. It will not be costly. So in this case, if you simplify this will give us 2s squared. Then if you add this, we'll get plus 6s plus 4. That's what we have here. Then now you come and move your negative inside and remove the final bracket. So that will give us what we have is equal to 0. So at this point, you know, we have a quadratic equation in x was squared, but the s squared term here is negative. So that means we have to move, okay, each of the terms here to the side after we have combined. But in any case, I rearranged and combined at the same time. So I move this one to the side, which will give me positive 2s squared. So in my mind, I'm moving to the side. I'm writing it here, and here too, it was negative. If I move to the side, to give me plus 6x. And now I'll get 24 minus 4, which will give me 20. Then I'll also move that one to, okay, this side, which will give me minus 20 is equal to 0. Because if I move everything here, I will get 0 on the side. Okay, so that's what we have. Somebody could have kept this one, negative 2s squared, then minus 6x, okay, then, okay, plus what, 20. Then you divide through or multiply through by negative, which will still end up giving you this. Because when solving any equation, make sure that your leading coefficient is what, positive. Okay, so now what do? We know, oops, I think I left something out here. Okay, so let me quickly do the, what do you call it? Oh, so no, I didn't, there's nothing wrong. Okay, so after doing that, you can see that what we have here, this equation can be reduced before solving. So I divided through by 2. Remember, I've told you before you solve any equation, check whether it can be reduced. Okay, so that you make it very simple to work with. So if you divide through by 2, okay, you do it mentally because one side contains more than a term. If each side contains a term each, then you show the division by what you are dividing, okay, by. So it will be this over 2, which will give us x squared. This over 2 give us 3x. This over 2 give us minus 10 is equal to 0. So now, because the leading coefficient is 1, remember we can do the factorization without the groupings, a special situation. So in this case, how do you do the factorization? Because this is in x, you get your, let me go and pick the, so this is what you do. You have your two brackets there, x, x. Okay, you keep your x, and you go and look for the factors of minus 10 that you multiply, you get minus 10, you add, you get what's 3, and that will be positive 5 and negative 2. So it will be plus 5, you attach, then minus 2, and that's equal to 0. So that's how come I got the side, or okay, the expression that I have here. In this case, I mean, I'm talking about the factorized form that I have here, and equal to will make it an equation. So take note of that. So at this point, I can go back to my laser having explained that. Okay, this will give it. So after you have factorized this side, because here we are solving by factorization, any equation, quadratic for that matter, that you are solving, okay, check whether it is factorable. It can be solved by factorization before you think of any other method. Okay, so here, this factor will be equal to 0, or this connector is very critical. X minus 2 is also equal to 0, this factor. Solve for x in each case, then you come and draw your conclusion. Okay, so therefore x will be equal to minus 5 or 2. Okay, somebody could have put here minus 2, minus, it doesn't really matter which of your factors come first. You end up getting the same, okay, solution or value, or values for x in this case. Okay, and now quickly, let's go and look at the question 3. Okay, question 3. Okay, A, given that, so we given, you can see that this is a matrix because you have it in a square bracket. This is also a matrix, so it's not determinant. Those of you who thought as such, you need to know the difference. The determinant, the sign, okay, will be, there wouldn't be, so it will be this. There wouldn't be any, so it will be just lines. This way, there wouldn't be anything here and anything. Immediately you do this, becomes a square bracket, it makes it a matrix, not the determinant of the matrix. So please take note. So you are told that this matrix here is equal to this matrix, and you are asked to find the values of P and Q. Okay, so in this case, you know, okay, we just have to use equality of matrix. So if two matrices are equal, then their corresponding entries must be equal. So in this case, what do you do? Solution question number 3A. Okay, given that this matrix is equal to this matrix, what do? I have two unknowns, so I have to make sure I create two equations with two unknowns to solve. So in this case, okay, let me see. I can do 10, okay, must be equal to 3q plus 1. This entry must be equal to this. I decided to write, okay, 3q plus 1 is equal to 10. I decided to write this one, okay, on this side is equal to 10. You can also write 10 is equal to this. Now, because you, after equating this corresponding entry, you see that you have only an equation in one variable, q. You can continue and solve. So if you solve for q, you are going to end up getting q to be equal to 3. Okay, then you label this as equation 1. Okay, then let's see if you can also form an equation in what? In P. Okay, so this equation here is in P and Q. Okay, so obviously, so this expression here, I should say, is in P and Q. So, okay, this term here, which is this entry, must be equal to this entry. So on that note, P plus 2Q should be equal to 8. So that's what you have here. That becomes equation 2. Okay, then you come and substitute equation 1 into equation 2, because once you know the value of Q, indirectly you know the value of P. So equation 1 into equation 2. This will always be too short to take a line. So you bring comma, then P plus 2, your Q is 3, is equal to 8. You solve for your P and your P will be equal to 2. So you come and draw your conclusion comfortably. Therefore, P is equal to 2 and Q is equal to 3. Okay, so that will be it for the A. So let me go for my, okay, laser pointer again. Okay, all right, so I guess this is what we have. Okay, so let me go for it again. Okay, so again, if you are looking at this, okay, what we have here, obviously B, we are told that also we are dealing with find S if, okay, this time this is equal to that. So if you look at it critically, you can see that again, we are looking at what? Equality of what? Of what? Matrices. So what do we do? Only that the other one, you have a simple matrix equal to another simple matrix. So you didn't have to perform any algebra before, okay, equating the corresponding entries. Okay, but this one, you can see that we have to multiply this before we can equate. So now what do we do? Given this is equal to that, so copy and paste whatever you were given. And this is an equation, so you start with implication. So we need to work on this. Okay, so we are going to multiply this matrix and this matrix. Remember, before you equate, you should have a single matrix here equal to another single matrix. But here you can see two matrices. So this call for multiplication. So what do we do? Okay, row by column. So it will be 1 times 3, which will give you 3, then plus 0 times 0, which will give you 0. Then 1 times 2, which is what? 2, plus 0 times 1, which will give us 0. Then it will be 2 times 3, which is 6, then plus s times 0, which will give you 0. Then 2 times 2, which is what? 4, then plus s times 1, which will give us what? Okay, x. Okay, so obviously this can be the one not involving s can be simplified. So if you is equal to what you have here, you keep this side. If you come and simplify the one that could be simplified, you get 3 to 6, then this you cannot simplify, it will still remain 4 plus x. And you can see that this entry is equal to this entry. This entry is also equal to this entry. This entry is equal to this entry. So the only situation where we can say that this matrix will be equal to this will be when the final entries are the same. So this entry must be equal to this. So this implies that 4 plus x should be equal to 3. If you solve for x, you get x to be equal to -1. So that becomes the solution to question, okay, 3 what B. Now to our last question, okay, which looks somehow tricky and busy, okay, because this matrix that we have here, we know we can see the order. The order is 2 by 3. This one is also 2 by 3. All the matrices that we've dealt with so far, we're looking at what? A 2 by 2 square matrix. So the same concept, okay, the same concept. Okay, so let's see, find x and y. So meaning we are finding the values of x and y. If the matrix B is equal to the matrix C, given that the matrix B, which is this, and the matrix C is what? That. So solution, given, you know, your matrices are what you extract first. So these are the matrices. However, there is a condition that you are supposed to use to find your y. So you come and state the condition. So part B, matrix B is equal to matrix C. So it means, okay, this matrix here must be equal to what? This what? Matrix. Okay, so I think that should have been part of the steps. I should have written this implies that this matrix here is equal to this matrix. But I did the comparison straight away. Okay, so please take note. Let me see if I can quickly do that because it should be part of your solution. Okay, this is a subjective question. So let me see if I can quickly do, okay, insert that particular step, which is vital before moving. Okay, so all right. I have now inserted the vital step that I was talking about. Okay, so it means this particular matrix here, let me go for, okay, so the laser pointer. So this matrix here, which is your B, should be equal to the matrix for C. So again, for two matrices to be equal, their corresponding entries must be the same. So here, all that you need to do is to equate what corresponding entries. But check, if I look at this entry, it involves only x. Okay, this involves what? Just a constant. Okay, so I can form my equation and to easily help me find x. You can equate, someone can also equate this and this, but pick for the one that when you form your equations with, it will be very easy for you to solve. So I equated this first element here or entry to this particular entry, and it will give me an equation strictly in x, and I solved for x. And again, okay, if I want to find y, yes, I can equate this to this particular one to this entry, and it will give me only an equation in y, then I solve. Okay, if you come and involve xy plus 4, then it's equal to -2. That could also be an equation, a valid one for that matter. In that case, you have to come and substitute the value of x, okay, before you can find the value of what? Y. And obviously, you know that will be more work. So anytime you have such a question, what you do is check for the possible equation that when you form, it will be very easy for you to solve. So if you can form equation involving only one variables, okay, for both of the variables and solve, fine, you do so. Otherwise, then you involve the two variables. So someone could have also used minus x plus 7 is equal to 10, and that will help you solve for your x as well. Then you still end up getting the x to be equal to -3. Someone, okay, if you come and use this, okay, that is -4 is equal to this, then it means here your equation that you form will involve two variables. So you have to know one before you can find the other. Okay, so I guess my point is well made. So here I form these two simple equations in one variable each, and I solve for the variables that I've been asked to find their values of phi. So in this case, I will come and draw my conclusion. Okay, therefore, x is equal to -3 and y is equal to what? 2. Okay, as simple as that. So this becomes, okay, the solution to the class, okay, the team assignment. Okay, so thank you very much for your time, okay, and for sticking and staying with me. May the good Lord continue to bless us all. And please don't forget to subscribe, like, and share, and equally comment if there is anything that you'd want to bring to my attention. Okay, bye-bye.